طيب بسم الله الرحمن الرحيم. Let's continue with the remaining few slides. Can you see my screen, شباب?
Yes, doctor.
طيب بسم الله الرحمن الرحيم. Last time we emphasized and we went through the characteristics of the database approach. Okay, then we started by looking at the limitation of the file system, which is the other approach or an old approach for specifying and storing data. As we mentioned in the file system, we said that the data is stored in a separate file. The data is manipulated by a set of application programs. Okay, and it is if the data increases and the number of application programs increase, it will create a complexity for managing such data that is spread over many files and accessed by different types of programs. We looked at the problem of redundancy, that the data might be redundant, or we do have the same data and we duplicated data in different files. And sometimes we mentioned that we might have an inconsistency between the different types of copies of the same data that is located at different places, and we explained why. We also emphasized in the file system that we do have a problem of accessing the data. That means, as we mentioned, that for each file that contains data, it needs some specific programs to be used to access that data. That means each time we do have, if we want to have a new task that should be done on that file that contains your data, that means you have to write a new program for that will do that new task, because as we mentioned, each data or each file is accessed by specific programs to do some specific task. Now, if you have to do a new task, that means you have to write a new programs. We said because of the scattered data, which is distributed in different places in various files, those files might have different format. You might, like that's in simplest way, we might have a text file. In another place, we might have an Excel file. In another place, we might have an Access file. It depends on the data format. That means you have to write the appropriate, let's say, program to access that type or that kind of data format, because the data is not unified in its format. Okay, it's not like, for instance, when you have a database. Okay, we do have one format, and we mentioned, as we gave an example, when you do have different browsers accessing the same database, Google database. Okay, because the data is unified, we don't have such problem. But if the data was different, that means each browser needs to access some specific data. Okay, when you do have, for instance, a Word file, you cannot use an Excel application to read, for instance, a Word file, and vice versa. That means for each data format, you need some specific program to access such data. We mentioned the integrity problems as well. We said that sometimes there are some constraints which are integrity constraints, should be inserted or should be part of the program code. Okay, and you have to force, for instance, if you have a new constraint or you want to change or update the constraint, like an account balance should be greater than 0, you need at that time to force and change the program that is enforcing such integrity constraint. We looked at the atomicity of update. We said we might have the problem of atomicity. We have already explained what is atomic transaction, and we said sometimes we might not update the database, okay, or we might update only part of the data and we leave the other one without any update, and we will create inconsistency in the data within the database. Also, another limitation, we mentioned the security problems. We said that the problem of having the data or files at different locations. We might have secure or might secure one place and we leave the other place unsecure, and people or attackers might attack that unsecured place or that unsecured file, and so on. We mentioned the concurrency in database approach. Okay, and we gave an example of airline reservation or hotel reservation. Okay, where you do have multiple users accessing the same data at the same time, and we need to have such concurrent access by multiple users to that same data. And sometimes, if we do have, and that concurrent access is controlled by DBMS. If you remember, we said that within the DBMS, we have that specific program that will control that concurrency. Okay, and because of the existence of that module or that program inside DBMS, we have that characteristics of concurrent transaction. We can do hotel reservation or flight reservation without having any problem, because automatically the data is updated and there is no inconsistency. However, for the file system, because there is no control concurrent access within the file system, and this can lead to the inconsistencies of the data. We might have, if we are using the file system in airline ticket reservation, for instance, okay, we might someone who is, let's say, let's suppose you do have two agencies, okay, and they do have the same database, and at that time there were two people or two customers asking to buy a seat within a specific flight. Okay, in one of the agency, the transaction has been done to the end. That means that client or customer has went through all the, let's say, the processes and bought the ticket and took, let's say, the last seat on that flight. Because of there is no control of that concurrent access in the other agency cannot see, and the database is not updated, and the people working there, they cannot see that the seat has been already taken, and they will sell the same seat to the other customer, and we do have inconsistency in the database. In one place it has been sold, and the other place it's still available. Okay, and this is the problem of let's say, when we do have concurrent access. If that concurrent access exists in the file system, we might have such inconsistency, because the control of concurrency is not done automatically by some specific software or programs. It needs to be done maybe by hand, by the user or the employee who is working at that agency, for instance. It's not like in DBMS, automatically there is a program that will automatically activate the update. Anytime there is something new to the database, that module will do its task and update the data accordingly. We said with problem with the data redundancy, we have a wastage of space because we do have duplicated data. It causes more maintenance headaches because of the data being located at different places. That means, imagine that you do have 100 places where you do have the same data. Okay, if you have to do update on one place, you have to go through all those 100 places and do the same update. Okay, for just changing maybe one data, changing maybe an item account or an item number in one database. That means you have to go through all that 100 places file where you do have those files located and do the changes over those files. It's not like where if you have a single repository place, like in a database, you have one place where you have that data, and you do only one time change. You change it once and it is done. You don't have to go through all those copies of the same file that are scattered over many places, and compromises in data integrity. Here we talk about, as we mentioned, when you change data in one file, we might have inconsistency which compromise the integrity. As we mentioned, the integrity is to have the same copy everywhere. When we do have DBMS, we have only one place. And we look at this diagram. That's why we said that we need the solution to overcome all those limitations of the database is by having DBMS. We went through the actors on the scene, okay? Now, in terms of the advantages of using the DBMS approach, we said in the DBMS, we do have control redundancy, okay? We cannot have many, let's say, the same copies repeating within the database. That means the redundancy is controlled, okay? And we are not wasting any space. And here we talk about, which is known as a data normalization. Data normalization, that means you have the information is stored in one place, which saves you a storage. And sometimes you need to have denormalization. Here we talk about denormalization, which means that sometimes you need to use control redundancy. Here we talk about controlled redundancy. And when we do controlled redundancy, what do you think, Shabab?
Controlled redundancy?
Yes, we said in file approach, we have redundancy. In database approach, we don't have redundancy. But sometimes we need to have the redundancy in DBMS, in the database approach, but at this time it is called controlled redundancy. Yes?
يمكن نعرف لها مكان معين عشان يمكن إذا وقت احتاجناها نرجع لها.
We said controlled, huh?
Okay, but why we need it يعني هنا?
Yes, why we need to have redundancy in sometimes, in some environment or some databases, we intentionally have redundancy of the data. So what is
redundancy for a whole data set?
Yes, for the whole database, yes. What will be the approach, or what is the, let's say, the reason for having, but with the condition, with condition, I am saying it is controlled. It is not just redundancy. Okay, it is not just redundancy. We have many copies of the database in many places. Here we talk about control. نتحكم في redundancy.
We know where it is, where it goes, or in one place.
We know where it is. Now we know where it is. Now the question is, what is the reason of having
backup, Doctor?
Okay.
Yes, one of the, yes, it can be a backup. What is the other main reason? Okay. When you do backup, that means you have one place. Okay, just let me. When you do have a backup, okay, let's say for instance, when you do have a backup, we have one database running, and the other one is as a backup. It is considered as a backup. When we say a backup, okay, this is running database, okay, and this one will be as standby database. That means now people, okay, who are accessing, let's say, the database, okay, or who needs to interact with the database, they are using this database. They are not using the backup. Don't confuse it, Shabab. When we say redundancy, it's not like we have a backup. We always, as a measure of security and not to lose the data, we always need to have a backup of anything. Okay, whether it is database or anything you have that is contained in your data or that is stored in your data, you need to have a backup as a precaution. If this, for instance, if this database or the system or the computer that holds this database is has a problem, for instance, at least we have a copy, another copy. But here, when you say backup, the people or users are not using the backup. The backup will be triggered, will replace the original one if this one is shut down or has a failure or anything, any problem. This is when we talk about a backup. But when we talk about redundancy, okay, imagine, Shabab, that, for instance, I do have here account department, for instance, okay, and I do have management department, for instance, and I do have another department, TS or IS department, for instance. Okay, now when we say we have redundancy, that means the same data is located at, sorry يا شباب for the drawing, but at least you know it is database, صح ولا لا?
Yeah.
Okay.
It's look.
Now the same database, أنا متعمد مسويها بنفس اللون. Okay, it is the same database. It is found at the account department, management department, and CSIS department. Now, this is different from what I said as a backup. And users in the account department, okay, users in account department are using this database. Management department users there, they are using this database. The users in CSIS department, they are using the same copy of database. Now here we do have redundancy, because the same copy is repeated or it is stored at different places, but it is the same copy. Okay, here we talk about same copy.
Same database.
Naam?
I said, Doctor, why we don't make them one database?
This is the question. This is my question. I told you sometimes we need to have controlled redundancy. Here we talk about controlled redundancy. Okay, controlled.
To make work.
What is the reason?
More faster.
Barakallah fiik. More faster. Imagine, Shabab, that, for instance, this account department is in Riyadh, for instance, and the management department is in Jeddah. Okay, for the same database, for the same entity, for PSU, for instance. For some reasons, they are not in the same place, or they might be at the same place in Riyadh, but at different location. There is a problem of, now, if we go back to our example, if we have the same database and we do have here different location, okay, these are the different departments, okay, and each time they need to access that database, okay, and sometimes because this department, for instance, is far away from where the database is located, it takes time, for instance, for the data to travel from the database to this department. It takes time to query, to get a response from this database because of the network that is connecting this department or this or any department to the database. It takes time to get the information, and we need to get the information, we need to get the data from the database as fast as possible. Okay, so one solution of that is for at each department or at each location, we store the database. Okay, now the accounting department doesn't have to send requests to this database to get data. The database is on the same location where I do have accounting department. It will be faster to send and get a response. For the management department, for any query to the database, it will be done on the database stored within the same location and management department. And the same thing applies for this example. And this is for the sake to make the query of the database to be faster and quicker. But with one condition, Shabab, with one condition, that we should control that redundancy. What does it mean we should control redundancy? If that accounting department will do some update on the data, the update should be reflected on all other databases by any way. Okay, بأي طريقة. We might have network, we might have someone calling accounting department, management department from accounting department. We don't care about how that data is synchronized. But at the end, if there is any update in one place of that same database, the other copies should be updated accordingly. That's why we call it controlled redundancy. It's not just redundancy like in a file system, it is controlled. And we mentioned, we intentionally تعمدنا شباب to have those number of the same database copy at other different places. Yes, I was hearing the question, Shabab.
I just want to ask about update, problem of update, but you answered it, Dr.
Yeah, there's no problem. As long as Shabab, as long we mentioned it is controlled, خلاص. Okay. It is controlled redundancy. It is not just any type of redundancy.
Doctor?
Naam?
Doctor, so is there a difference between having redundant database and a backup?
Redundant, say it again, redundant?
Database and a backup?
No, there is, for the term redundancy. Redundancy means you have one original copy, okay, like this one, okay, and we will have another copy which we are not going to use it right now. It's like, for instance, let's imagine, Shabab, you do have two mobile phones, okay, one you are using one of them and the other one you put it, you leave it at home. You just, as a precaution, you will say, in case my mobile phone goes wrong, or that there is a problem or failure or any problem with my mobile phone, at least I do have another one. I do have another device at home. Okay, just in case. We say that you have redundancy. You have redundant mobile phone. And the same thing, the term or المصطلح redundancy is the same, whether we say that I do have a backup or I do have a different copy, we do have redundancy. But the difference is where, when we say I do have redundancy, it doesn't mean automatically it is controlled. If I told you here, for instance, if I don't say it is controlled, I will say I do have redundancy, that means automatically what comes to my mind, the problem in the file system, like file system. Maybe one database is updated and the copy of the same database in other places, it is not updated. But when I mention controlled, you automatically have an idea that we will not have a problem of that inconsistency or the integrity of the data. We know because it is controlled, that means anytime I do changes, will I do update in one place, automatically I do have the other place updated. And that other place will update the content of the same data. Clear, guys? Yes, Shabab?
Yes.
Okay. Now, the other thing, let me go back to, okay. We said that we do have control redundancy. To improve this is what we mean, to improve the performance of the query. Performance, which means the speed, okay, speed of accessing the data. That means we have already emphasized it. Also, restricting unauthorized access in the database approach. Okay, you can have a restriction. You can set up a control access. No one can access your database unless he is authorized by having a username and password, for instance, because we do have here multiple users accessing the same and they are sharing the same database. Okay, that means of those users will have some types of account that will let them access the database, and we are sure because we do have only one place that stores the data, and we can control who has access to that database and what they can do and so on. Okay, and sometimes here we talk about privileged software, like for software that are part of the database. If you remember last time we talked about the database administrator, who is responsible, for instance, for creating account inside the database. This is known as a privileged software. That means only the database administrator will have access to that part of the DBMS that will let him to create a new account within the database. Another characteristic or advantages of the database approach is we do have what is known as indexing, buffering and caching, and query processing optimization. Indexing, does anyone has an idea what is indexing, Shabab?
That means, Doctor, for each record there is index database or ID?
Addressing,
like in the book, Shabab. If you pick up any book, if you look at the end of the book, okay, normally the last pages, we will have index. Index, that means if you are searching for some keywords inside the book, you don't have to go through the whole book page by page and search for that specific keyword. You go directly to the end of the book, go to the section where you do have index, okay, and all the keywords are ordered in alphabetical order, and it is mentioned for each keyword in which page you can find that keyword. Okay, it will quickly help you to locate and localize the keyword within the book. Otherwise, you have to read the whole book and go through page by page to search for that specific keyword. But by using the index, okay, when we talk about indexing, the same thing. When you search within the database, instead of searching record by record, place by place, table by table, there is an index inside the database which help, let's say, provide the query quicker. When you type in a keyword and you search within the database, automatically the DBMS will go to the index, will search only for that keyword within the database, within the index, and it finds, for instance, that keyword is located in a student table, record number 20. Automatically, it goes to that place and gets the information and provide it to the user who made that query. And this is we hear it is a quick. This is, let's say, helps the search within the database. Okay, this is one of the advantages. Now,
for each word, there is index for all the words or record or what?
It depends of how the index was done. When you talk about indexing, it is the responsibility of the people who are creating the database and physically storing the data inside the database. They will store it in some specific way, in some specific structure, which is called as index, which helps. There are many algorithms that will help to do such order and indexing. Okay, we are not saying it is done on the basis of keyword or on the basis of the tables. It is usually done on based on the files. Okay, there will be some files that will contain on purpose that have been like in the tree structure. Okay, you can find tree structure, or there is another type which is known as a hash data structure. Okay, that are easy to be used and modified, and they are automatically helping, let's say, the DBMS to do the search within that database quickly, okay, and sending the data to the user who has made that query. Okay, we do have another advantage, which is buffering and caching. Like in any computers, you do have a buffer or caching. That means inside the DBMS, okay, there is a memory. Okay, in that memory, all the recent query that have been made to that database are stored in cache. That means if I search for right now, if I search for a student who have GPA greater than 4, it will return to me that the result, and the copy of that result is stored in a cache, in a memory. If I do the same query later, instead of searching again inside within the database to get the same result, to be more quickly, it will go to the cache and get the result quickly to the user. Like when you do what you do in a browser, when you access some websites, okay, the first time, maybe it takes time to get you to open that website. But when you search, when you want to open the same website later, you will get it quickly. Why? Because at the second time you get that website from the memory, from the cache that is stored within your computer. Yeah, now.
Doesn't this compromise the security of the data?
Say it again.
Does this not compromise the security of the data?
Doesn't compromise security of the data. For the database, we said that to have a query, okay, it will compromise the security of the data if the credentials are stored in cache. But as the data itself, the first thing that before querying, before accessing the database, you need to have permission to access the database, to search within the database. But as long as the data is stored, when you send the query, okay, that query is, instead of executing the same query twice or 3 or 4 times, okay, if it has been executed once, we don't have to execute it again, second time.
Okay, thank you for the
answers. You're welcome. We do have also what is known as a query processing and optimization. Query processing and optimization, it is one of the modules of the or programs that is part of the DBMS, which is responsible for choosing the according or an efficient algorithm for query execution. Okay, when you send a query and you send the complex query, for instance. Okay, I want to search for this is not a complex, but just as an example, I want to search for XYZ student with his name who has his mobile phone terminated by 754, and he lives in Riyadh. His age is 22. His GPA is 3. So I will just make a complex query. Now, how that complex query is executed, in order to get you the response quickly, there is a module inside the DBMS that is responsible for optimizing the query. Optimizing, that means it will look at the best way to execute that query faster and get you the response and the result. Okay, and this is one of the advantage that you can find it in any DBMS. We do have a backup when we use database approach. We do have a backup service, and we do have recovery in case of you do have a problem with your original. Automatically you can get the original data from the backup. We might have graphical interface, different graphical interfaces for different users. Okay, if you remember, just as a simple example, you are using different browsers. That means you are using different graphical interface to access the same database. And the same thing applies for any types of database. Maybe the same guy at accounting office has a program or an interface which is different from the guy who is working at the management office or department, and they are accessing the same data. So here we said that they do have a different graphical interface, and of course it represents a complex relationship between the data. Okay, as we mentioned last time, we said that you may have a table of students, you may have another table of courses, You might have another table of prerequisite courses, another table containing the instructors who are teaching those courses, and all those tables have some types of interaction between them. And because of using database, it is helping us, it facilitates to create such complex interaction and relationships between those different types of entities or tables. It enforces
like PHP My Admin provide the graphical user interface.
Yes, this is that for the DBMS. Yes, for specific, this is a DBMS for a PHP admin. But here we talk about different applications. Accessing, yes, applications will have programs accessing that PHP admin, that database that has been created using the PHP admin. Okay. Enforcing integrity constraint. Here we talk about referential integrity, as we mentioned, because we said that you do have one table that does have a relation with another table. Now here we talk about the referential integrity, which means if the data is changed in one table, automatically the other table should be updated. Okay, this is what is known as a referential integrity. We will be back. We'll talk about referential integrity and key uniqueness in another separate chapter, inshallah. Key uniqueness constraint, which means that when I do have a student ID, we should not have the same student ID for two different students. This is known as the key or uniqueness constraint. That means each student within my database should have a unique ID. We don't allow to have two students having the same ID, for instance. And sometimes you do have some business rules, some constraint. That means based on your business, you might say that no employees, for instance, should have worked extra hours more than 30 hours per month. This is based on your business. This is considered as a business rule, and you have to implement it. You have to enforce it inside your database. And when we use database approach, we can enforce such business rules. We specified last time now.
Sorry, I had a question. So does the encryption of the data, does it change the structure of the database?
Say it again. Say it again.
So the data in the database, it's not encrypted, right? It is not encrypted.
It depends. It depends how the way the security you did the security on that database. Sometimes you can you might encrypt it. Sometimes you might not.
If we choose to encrypt the data, does it affect the structure of the database, or it does not affect?
Say it again.
If someone chooses to encrypt the data,
yes,
does it affect the database, or it does not?
Who's that guy who is encrypting the database?
The person, the database manager, the guy who's managing the database.
Normally, the data is not encrypted. The data itself, unless it is, let's say, confidential data. For instance, the passwords of the users inside the database, it is encrypted. But the data itself should not be encrypted unless it is a confidential data, and there will be some way to decrypt the data itself. Okay.
Thank you for the answer.
Okay. The deductive database, we have specified last time about the deductive database, where, as if you remember, when we mentioned you do have date of birth. You store the date of birth, and you want to deduct the age of some users. Okay. We do have such type of database. Trigger, that means there are some rules that are activated if there are some updates. Trigger, that means if I do update, let's say, for instance, as we mentioned, in your business rule, you specify that no one should or can work more than 30 hours. Okay. And during the input of the update of the data, someone has entered 35 hours as an extra hours. This, which, let's say, doesn't abide to the business rule, what you can do in case of such circumstance, you might write a program, a trigger, a message, or it's like you are sending a warning message to the account, to the administrator, or to the person who is trying to update the database, and just send in a message and triggering some action to say that this is not allowed, or if the database will accept it for some reasons, at least you have to send a message to the database administrator saying that this rule has been violated, for instance. And sometimes you do have a stored procedure. Stored procedure, that means you will have some rules that you want to enforce inside your database. You will enforce those one. As we mentioned just now, right now, I said that some rules say that no one should work more than 30 hours. You will write a program inside the DBMS that will verify whether that rule is obeyed or not. Sometimes anyone who is trying to violate that rules, that procedure will prevent any user from violating that rule, for instance. These are some advantages and some characteristics of you can find it in any database approach. There are some places or some circumstances where it is not advisable, for instance, to use DBMS. We say not advisable, that means it is desirable to use the file system. Okay, it doesn't mean that the DBMS will not do the job, but we say in circumstance, for instance, if you do have a small database, okay, and the applications that are accessing the database or the data are not changing, or you do have a stable data that will not change continuously, you might opt for using a regular files approach. Sometimes you have real-time data. Okay, when you have a real-time data, you are receiving real-time data, you need to deal with that real-time data. Sometimes it is better to use a file system, because using the DBMS, it will create an overhead, because it will trigger all those modules will work, and each time you need to have access to the database, you go through database catalog and so on. That means there will be a lot of actions within the DBMS, which creates an overhead on that DBMS. Sometimes embedded systems with limited storage. Sometimes you do have some devices that have storage embedded on those physical devices, and you do have a limited storage. Instead of, let's say, in this circumstance, you cannot use a DBMS. You will opt for using a file system because of the limitations of the size of the data that can be stored. And if you do have no multiple users accessing that data, you might choose to use a file system instead of DBMS. This is, let's say, some places or some, let's say, characteristics. If they are available, it is advisable to use a file system, but it doesn't prevent you from using, for instance, the database approach.